Let's go ahead and take a look at number 7 and number 8 here. Number 7, we're looking at two different concepts here: the instantaneous velocity or rate of change and the average rate of change. Now, we do similar calculations to find this. Just for the instantaneous, we get closer and closer to a point which is related to derivative, which is what we'll use in the next units of applying derivatives. And so to find the average between 5 and 10, that's it. You just plug in the values, right? And it's the difference quotient that we've seen from the very beginning of this class. The difference quotient, we're comparing the difference between the two values over how far those values are apart, right? From 10 to 5, it's 5. And so that helps you find an average velocity in this situation. Now, if we're going to find an instantaneous velocity of 15, we would do a derivative to find the exact one. But here we're using a quantitative approach. We're using numbers to do this. And so we're going to approximate the instantaneous velocity at a time 15. Just pick values very close to 15. And there are multiple ways to do it. I picked kind of an average over some time, 15, some value over that is an approximation. It's so close to 15, I could use that value. You can pick 15 and 15.001, 14.999, and 15, right? It's still an estimate, and that's why there can be various ways to do this to find those values, okay? Now, we learn derivatives help us find the exact instantaneous, so that we wouldn't need these techniques, but this helps us develop the concept of what we're doing. Number 8. We have a graphical situation. There's some questions that we would have, right? Now, this situation is related to the altitude of a plane, which is going to be a continuous thing. And so that's something to keep in mind, right? That although we can't see the graph, we know it's going to be continuous. It's a continuous function given the context of the situation, right? The height of a plane, well, there's no way that a plane can just stop and disappear. Potentially now with all those unidentified aerial phenomena, AUPs, maybe this can happen now, but within the current constructs of our limits, we will have a continuous function here. And that's where all these answers come from. The limit of h of t as t approaches 2 at t approaches 1 is 10. As it approaches 2 from the left side, that's over here. And that's where those numbers come from. And then I have my explanations for that. Of it's continuous here. The true or false question, right? We're going to say it's true because, again, this continuous function, right? I would think that the right side would be 12 also. It's not going to just jump up and down. It's not going to be discontinuous in some way. So that's how I could do that. Intermediate value theorem will allow us to answer E, right? That's somewhere in between. It had to be 9. And then the average comes back to finding the average, which we did in the previous problem.